Okay, so an RLC series circuit with R equal to 600 ohms, L equal to 30 millihenry, and C equal to 0.05 microfarad is driven by AC source with frequency and voltage amplitude given by 500 Hz and 50 volts respectively. What's the impedance of the circuit? What's the amplitude of the current in the circuit? What's the phase angle between the EMF of the source and the current? Okay, so let's draw a circuit first. And there's the resistor, and there's the capacitor, inductor, and these are connected to an AC source. Okay. R, C, L. Okay, the first thing we want to do is calculate the impedance, and a good habit to get into is to calculate XC and XL right away. So XC is 1 over omega C, 1 over 2 pi FC, which is 1 over 500 Hertz, and C is 0.05 to 10 minus 6 farads. So XC works out to this is okay. What we'll do is we'll borrow this 100 there, so that's 2550 pi. So this is 10 to the power 6 over 50 pi ohms, and this is equal to 6,366 ohms. Okay, and then let's calculate XL. It's kind of a large XC, but anyway, XL is omega L, which is 2 pi FL. 2 pi into 500 Hertz, and L is 30 into 10 minus 3 henries. There's 2 zeros and 1 zero, that kills that, so 15 times 2, 30 pi. 30 pi ohms. And okay, so this is 94.2 ohms. XL is that. Alright, so looks like in this circuit XC is the largest impedance. Okay, what is the impedance of the circuit? So let's calculate the impedance of the circuit. Okay, so the impedance of the circuit, Z is R square plus XL minus XC square. Okay, so this is equal to 600 ohms square plus 94.2 minus 6,366 ohms square, and this works out to 6,300 ohms. So Z is 6,300 ohms, I guess. And as you can see, most of the contribution is coming from the capacitive impedance. Alright, so what does part B ask? What is the amplitude of the current in the circuit? And so we know that the voltage is given by V0 sine omega t, and the current is given by V0 over Z sine omega t minus phi. Alright, so the amplitude of the current is I0 is V0 over Z, which is 50 volts divided by 6,300 ohms, which is 7.9 milliamps. So that's the amplitude of the current, and I guess we have enough room to, what is the phase angle between the EMF, and C, the phase angle is given by tan inverse of XL minus XC divided by R, which is tan inverse of 94.2 minus 6366 divided by 600. Alright, let's do this. Second tan inverse of okay, so that is minus 84.5 degrees. Phi is a phase angle of minus 90 degrees would be a purely capacitive circuit, and since we saw that the impedance of the capacitance is the greatest, it's almost a purely capacitive circuit. This is almost a purely capacitive circuit. Okay, that does this problem. So let's stop.